Okay, so today we're going to be talking about something new in this chapter, and this is going to be the chapter on vibrations and waves. And what we're going to be talking about is things that are going to be repetitive through time. So we're going to be talking about a special type of vibration and wave called simple harmonic motion, and it is simplified SHM, simple harmonic motion. Simple meaning we're only going to have one object that's going to be attached to a spring. So we're going to have a mass on a spring. Harmonic meaning that it's going to be a repetitive motion. So what we're going to be looking at is periodic or repetitive motion. So over time, we're going to be talking about something that's going to be going up and down like this, or something back and forth like this. Okay, so an example would be a trapeze artist. So you've got somebody on a trapeze going back and forth and back and forth. So it's repetitive motion. We also have something like a grandfather clock. The pendulum on the back grandfather clock goes back and forth and back and forth, as well as a bungee jumper. So a bungee jumper jumps down and then it's going to be going up and down and up and down. Another example would be a metronome. So people that are in music or band, the old-fashioned metronomes would click back and forth and back and forth. And that's repetitive motion. It just keeps going and repeating itself over and over. And this is what we call simple harmonic motion. In our case, in physics, we're going to be talking about a block that's hanging from a ceiling with a spring, and they call it a spring mass system. So we have a spring and a mass. And if I pull this down a little bit, if this is my equilibrium position, I'm going to pull it away from its equilibrium, and if I release it, the spring's going to go up and down and up and down. And so it's going to oscillate around this equilibrium position, down, up, down, up. So this is the down part, and this is the up part. Okay, so over here we have a positive X, and then down over here we have our negative X. Okay, so let's talk about the same spring now, and what we're going to be doing is we're going to be putting it on its side. So we have the exact same situation. We're going to have an X equals 0 equilibrium position, and over here we're going to push the spring in. We're going to compress the spring, and if I release it, it's going to be compressed, kind of like a pinball machine, and then it's going to be released. It's going to go to equilibrium, past equilibrium, and then go back and forth, oscillating around the equilibrium position. So we're going to talk about a special force. It's going to be force, and this time we're going to have a little S underneath it, meaning spring. It's an elastic or a spring force. We call it a restoring force, and the reason why is because this force is always going to be the direction towards equilibrium. So if I